the presentation here. So hello everyone, we are a Women Code community, and would like to give just a short introduction about what we do and what we are doing in our community. We are building a safe environment for women to thrive in tech, and well, let's get started. Our mission is to empower women to be at the forefront of technology and innovation. Our vision is to empower women in their tech career through education, mentorship, community building, and career service. We provide workshops, events, connecting members with the industries. We foster a supportive community through meetups, conference, raising awareness, and make more inclusive industry practices. We have a very important code of conduct to be followed, so please be very respectful with each other. We have no discrimination here about age, gender, religion, anything, or soccer team or anything. Just be respectful, and if you see anything that doesn't follow to our code of conduct, please send an email. Speak up. We are here. This is a safe space, and we needed to know about that. We have projects in the community regarding mentorship, book club. We have many projects. Please join our Slack and get to know a little bit more what you can get out of this community. CV clinic, and we have mock interviews. We have an open source platform project, lead code start group. It's about to start tomorrow. We've already have 300 people registered, so it's a very interesting one. System tech, system design track, and this start group, which we also having right now. We are a community built by volunteers, and all volunteers are welcome. I'm a volunteer, Go is a volunteer, and Wilson is a volunteer, and we need you. We have many work, we have a lot of opportunities. Anything you would like to contribute, from sharing a post on social media to be hosting an event as I'm doing, or co-hosting as Go is doing right now. So please join us and support and make this community grow and support even more women in tech. Some of the benefits of joining this community: yes, we are very friendly. We have a very good networking opportunities. You can learn, you can master your leadership skills. You can have some help and support regarding CV recognitions. Sometimes we have free tickets. It's always nice to have free things. And yes, we have unforgettable emotions. So this is about our community. And now I'm going to stop presenting, and I'm going to introduce our speaker today, which is the coordinator of this study group, which is Wilson. He is a full stack engineer. He has very technology experience in programming language, has led projects across the fintech, healthcare, edtech industries. He's also experienced in database design, web accessibility, and test-driven development. We also enjoy sharing knowledge, and he's a mentor and a volunteer as a mentor in our community, as well as an open source contributor. Wilson is also founder of a Digital Empower Foundation, which is an organization for training of young and rehabilitation in homes in Lagos, Nigeria. He is also founding engineer of Reporting Sites, a digital fraud prevention platform across Nigeria banking sections. Please, let's welcome our mentor and our instructor or speaker for today. Wilson, the stage is yours.
Hi, thank you. Thank you so much for the introduction. So I'm straight into it. Last week we discussed basic fundamentals of TDD, which is test-driven development. Today we're going to be a bit more specific. We're going into front-end technologies and React, so we're going to be specific speaking about TDD in the React ecosystem. That's like front-end ecosystem. So I'm just going to share my screen and go through my slides. I'm shaking. And yes. Okay. Awesome. Yeah. So okay. I mean, this is all about me, my name, and everything. Yeah. So we're going to be speaking on front-end test-driven development with React.js. Yeah. So that's like the topic for today. And I've written down the agendas. What we'll be discussing basically. I need to move this so I can see basically. Yeah. Okay. So we would be discussing component testing fundamentals, types of tests and testing strategies, test distribution strategy. So we have different types of tests, and it just speaks to which one should you write more, how you decide on which one to write, and all of those things. And then we have like the concepts, pitfalls, and best practices. I think a lot of people say, I don't know what to test. What do I test? Right? I mean, do I test this? Do I test that? So we're going to discuss some of the don'ts, some of the do's, and common pitfalls when writing tests. And we're basically going to go through a discussion on differences between unit integration and end-to-end tests. That's like the three most common tests you write in your front-end applications, even though there are some other ones like smoke, acceptance, but I mean, these three are the key ones that you would write in your front-end application. So we'll just go through the differences or like have a discussion on the three types, most common types. It's not all, but it's like the three most common types of tests you write in your React application. So let's go. Okay, so why do you want to test? Why would you test? Why would you write test? I think we discussed some of this last week. Also, it gives you enough confidence in your code. So I could write a piece of code, and if I refactor, I'm not changing the functionality. I'm just like refactoring, making things better. Maybe I wrote this code 6 months ago, and I'm in a much more better place as a software engineer. I'm like, what was I thinking when I wrote this? It could be done better. The functionality does not change, but I mean, you've grown as an engineer and you think the logic could be better. So you just want to refactor. You are sure that you're not breaking anything. So it gives you confidence in your change, prevents regression. You don't have to, once you like probably refactor, add new functionalities, and you had tests for the new functionalities that you had, you're adding or your refactors, you can be sure once you run your test and it passes, you can be sure the old functionality or what you refactored is still fine. So you don't necessarily have to open your browser, go start testing from login, this and that. You run your test and everything is fine. So regression is fine if you cover your code with test, basically. Also documentation, by example. Once I read your test, I should know what your component or what your code does. So testing is a form of documentation in itself. So that's like one of the other reasons why you test. And it also improves design via feedback loop. So like I've been saying, like based on my description, I write the code, I come back, I refactor or add new functionalities. Immediately without having to open my browser and do a lot of things, I can see if my test is failing. So I know, I've done something wrong or I've written something wrong. It doesn't meet the requirements, you know immediately without having to go into your browser and do all of those things. So it makes you sleep better at night in a nutshell, basically. So like some of the reasons, not all, I mean, why you would write tests for your code, your components, your React pages, and all of that. So yeah. So we have, like I said, we're going to discuss three main types of tests. We're going to discuss units, we're going to discuss integration, and we're going to discuss end-to-end tests. So this is like unit test. So unit test is like the word unit. I mean, you're testing a React component or function in complete isolation. So a part of your code or a piece of your code, you're testing in isolation without external dependencies, Redux or API. So you just like, say I have a button component or I have a user card or I have a profile component. I can test it in isolation without it interacting with other components. That's like unit test. Or I have a function that sums two numbers together. It doesn't have any external dependency. I can usually test it in isolation, right, and see it works fine. So that's like unit test. So these are like some of the use cases, or it focuses on rendering props and internal logic. Say I have a component that is like a button that receives props, say on click, a label, right? I could easily test that, oh, if the label is passed, this is done, or when the button is clicked, a function is called. That's like a unit test, because I'm testing the component in isolation. So it is fast, it is simple, and it's highly reliable because there's no external dependency. It's just a piece of your code. It is extremely fast. So that's like a use case or advantage. It is ideal for pure component or utility function, no external dependency, pure component. So it's like the same thing. So I give like an example, basically, right? So of unit test. Say I have a button that takes a label and an on-click callback, blackface. I could easily write test for it. Or when the label is passed, I expect the label to be rendered. Or when I click on the button, I pass the on-click prop, I click on it, the on-click is called, it's fine, nothing happens. So like that's a basic example of unit test. You test a piece of code, it could be a function, could be a component, could be an input field, anyone, just a piece of code in complete isolation. So that's unit test in a nutshell. I hope I'm not moving too fast. Okay, so we have integration test, which is another type of test. So you test. So unit test is testing just one piece of code, like in isolation, without interaction with other parts of your code. So you have a button, you have an input field, you have a select. You test it in isolation, or it works fine. Everything's fine. If I pass the correct props, it does what it's meant to do. Basically, test it in isolation. Integration test is you have an input field, you build a form with an input field, different components together. You had a button, you want to test how they would interact together. So unit is complete isolation, a piece of code separately. Integration is you bring different components together and you want to say, oh, this is the end goal of building this form. When you click on the submit button, the API is called. If the validation fails, I see the error messages on the screen if that's what you've done, or if that's expectation, or what is expected of your code to do. So integration is basically bringing different components together and testing them, how they interact together. Is it giving you the expected outcome, right? So that's like integration test. Yeah. So some of the advantages of integration tests, or some of the use cases, is basically interaction between parents and child components, different components together, like I said. Here you have like state changes affecting multiple components. So change in one place affecting multiple components, so interaction between different components, not just a component in isolation. So this is like an example of like integration test. Let's say I have a form, I have an input, I have a search form, I have the result underneath it. I type into the form, it filters, I see the result. So I have a search form, I have a table displaying the results. That's like integration test, because I have like two components coming together, interacting together, and I'm seeing the results, right? So that's like integration test. So, I mean, I tried to make sure everything shows, but I guess not enough space. So this is like a user list component where you have a user card, you have an API call that you make to the backend, you get your data, you do your map, or you do your checks. If there's an error, you render your error. If the API call is still in process, you render your loading screen. When you get your users back, you feed them into your screen, and you see your data being displayed. On the right-hand side is the test for this component. So I think I should just show the code. Yeah. Since this is a big cutoff. So, yeah. So this is the user list component. Just close this. So basically, I have my interface example of what the backend will return or the API will return to me. I have my loading states, I have my error states, and I have my user collection, which is like an empty array to start with. I basically have to make my API call. I get my users back, update my state. This is delete, this is edit. If there's an error from the API, this I'm setting it okay. It failed to load users. I'm checking basically. If it is loading, that means the API call is the promise is not resolved, right? I render this error, which is like okay, something is going on, something asynchronous is going on. If there's no user, I render okay. After the API is done, there's no error. That means it was successful, but no data. I render this, and finally I return this, right? So what should we test in this component basically? This feels like integration test because we have like interaction between this component and this component. We have like a user card component. So what should I test? Like most people like tend to ask that question. So I have a piece of test. I have like some tests. So basically, what I would test or what you should test in this component is one, you should test the rendering faces, like the log when it was loading. You need to test that okay, when the API call is being made, I'm seeing this on the screen. I'm seeing like my spinner or my design or my skeleton on the screen. If there's an error from the API, the error is shown on the screen. There's no unexpected behavior. This is how it should be. There's an error. You should also describe the edit phase because in the UI, I have like an edit functionality where you also call the backend and do all of those things when the API is done. Then you also have the delete. So you have like three things going on that page. You display your users, you edit, you can edit a user, and you can also delete a user. So that's like integration test. We want to test how different components come together to behave. So just going to okay. So this is what I was trying to like describe it, but there was not enough space. So I'm just going to open it up and just walk through it. So this is, I'm just testing that, okay, when I'm still trying to get the user from the backend, I'm showing a loading screen, which says, okay, I'm still making the API call. Wait, when the data comes back, I'll render it, which is like our expected behavior while showing the loading screen. So render the, so basically what I'm doing is all I've meant to do is when you are writing your test, a very good approach is when you're making API calls, very good approach is you, to make your test fast, a very good approach is you don't call the API. In some cases, you might want to call the API directly, but a very good approach is do not call the API because it will slow down your test. So the best thing to do is to create a mock. So you mock the API to like return the response that you would require actual API would return. So this is what I've done here. Basically mock Axios because I'm making the code Axios. Mock Axios. After every test, do a reset. And then, so basically I'm testing that the component renders as expected, right? So when there's, when it's making the API call and there's a loading screen, I'm showing, okay, I'm mocking this, I'm returning this. I'm expecting that the loading should show on the screen, which is my expected behavior, right? Which is fine. Then when the loading goes away, that means the promise has resolved. I'm checking, oh, okay, my users are showing up on my screen. So I'm doing the find by test. I'm checking that the names of the users are on the screen, which is fine, right? So the second test I'm checking is why no users are found. API is fine. I get a success response, but there are no users in my database, an empty array, which we have right here. If no users, render this message on the screen, which basically do this, we do our mock. This time around, we're returning an empty array for our users, which means that's the test we want to do. So we're not calling the API, we're mocking what the API would return in natural sense, and we're doing the check. So we mock the API, we render our component, and then we do the check. Oh, okay. We should actually find this on the screen, right? Because we didn't get any response. We got an empty array. So we do the test with all of that. I mean, that's fine. We're still testing the expected behavior, right? Default behavior of the component for the loading states, when the users are found, and the final one is when the API call fails, right? What should happen is our components working or our page working as it should if there's an error from the API. Same thing, we'll mock our API because we don't want to call our API. We don't want our test to slow down. We want it to be fast. We know what the response would be. We'll mock it. We render this and we check. Oh, okay, this is the error that we're getting. Everything works fine. So that's like we're testing the basic phase. Oh, everything should work as expected. Fine. Another functionality on the page is when you want to edit the user. So same thing, I write the describe log, write the tests, all of those things. Same thing when you're deleting the user. We do our mock, we render with all of those things, and we check. So basically, this is like an integration test, testing different components coming together, and you're checking, is it behaving as it's supposed to? Is this the expected outcome? Right, so check, we've covered everything in this component, what the component is meant to do. One, it's meant to render users. You can edit the user and you can delete the user. So we've tested everything right here in different steps and covered edge cases to check if you delete, what happens? If there's an error, what happens? If there are no users, what happens? Say, for instance, I decide to probably refactor this component or add more styles or add another functionality to say, oh, I can now add a user. I need to add the button, I need to add my form, and I'll also add the test. When I run my test, nothing should happen because I didn't change the logic, right? I just did a refactoring, added a new feature. So I can be rest assured that I didn't break anything by the time I run my test. So that's like an advantage of TDD or writing tests in your code. Another thing is you can add coverage to check, did I cover everything in my code? So by the time I ran this test, you can see all my lines, everything in my functions, everything is like 100, showing, okay, I covered everything based on the required outcome I have defined in my test. My code is working as expected, right? So integration test for the user list component. For the user card, we could basically write, it's just a simple component that takes in different props. There's no interaction going on here. It's just a simple component. You can test it in isolation. This is unit test right here. So if you want to test this component, just taking a bunch of props and doing simple things, right? This would basically be a unit test. So let's go back. So what I tried to add here as an image that it couldn't fit in. So I just have it here and I explained it. I hope we're following. So that's integration tests. You basically have different components coming together and you test them. So it's different from unit tests where you have a component, it's a simple component you test in isolation. It's a bit different, right? And the last one is end-to-end test. End-to-end test is different from unit, it's different from integration. Being you test a complete user flow. It doesn't run in your console. It can run in your console, but basically it runs as if a user is interacting with your application. It launches a browser when you run your end-to-end test. Launches a browser. You will see the click around based on what you've defined. Click different things. Say I want to write an end-to-end test for a login feature, right? I could basically write, okay, I think I have an example. Yeah. So this is an example, right? I say, okay, I'm using Cypress, right? This is Cypress for writing end-to-end test. There are other packages you could use to write your end-to-end test. Playwright, which is very good, but I've used Cypress the longest time, so it just makes sense to go what I was comfortable with. But I mean, Playwright is very good, similar APIs, right? It's not difficult. Cypress is also very good. I use Cypress a lot. So this is like end-to-end test. I visit login pages. I want to write an end-to-end test for my login feature, right? I go to my login page. I try to get my input field, my email input field. I type into it. It's like normal English, right? Get this, I type into it. I get my password, I type into it. I get my button, I click on it. I'm expecting that after logging in, takes me to dashboard. I mean, I could write other assertions there to say, oh, okay, if there's an error, show this. Maybe after you click on your login, there's a success mode that shows up. I say, oh, login successful. I could write it there and say, okay, there should be something on the screen that says login successful. So end-to-end test a complete feature end-to-end, just like the word. And it does it in a way where users would actually do it. Opens up a browser, you would see the way you click around as a normal user would do. It would replicate it just like that. So end-to-end test is very powerful for testing complex user workflows, something like checkout, a checkout page, something like that, sign-up feature, authentication feature. You would typically go for end-to-end test because you want to see how, when a user interacts with your application, what happens. Also for cross-browser testing, you could also use end-to-end test because you could use different browsers basically and see how it looks like on different browsers. How users will interact with it. It's very powerful. So end-to-end test. It's an example of end-to-end test. Very simple. Could add more assertions and all, but basic example of end-to-end test. So I've explained 3 testing strategies or types. You have units, which is testing code in isolation. You have integration test, which is different components coming together and we test how they behave together. Is it the expected outcome? Is it behaving in a funny way? Or, I mean, is it fine? Different components coming together. End-to-end is we test the complete feature end-to-end, the way a user would interact with it. I mean, like I said, browser would open up. You could see clicking around and all of those things. So yeah. So next thing is we're going to compare the 3 based on some criteria, right? Scope, speed, confidence, cost, and debugging. So for scope, for unit test, it is isolated. We test a single piece of code or a unit of a code in isolation. So I have this code, I want to test it in isolation without external dependencies. Just it could be a function, it could be one functional component, it could be a class component without interacting with any other component. Just like we saw with the button, it was just the button that was accepting props, or the user card that was just accepting the name and some functions like delete and undo, edit. And then we could just test it independently, no external factors. But for integration tests, we have multiple, 1 or 2 or more components coming together, and then we'll test it, interactions together. And then end-to-end is complete user interaction. Like we have the login feature, we have like checkout, or complex. So basically, sometimes what you would write with end-to-end test, you could also write it in integration test. Or what at the point where I make the distinction where, okay, this looks like end-to-end is when my integration test becomes a bit complex, when it becomes too long and I have to do this, I have to do that. Okay, this should definitely go for end-to-end because if I go back here, I could easily write this flow right with an integration test. It would work fine, right? You could also write it with end-to-end test because I mean this is very straightforward, right? But when a feature, a test starts to become complex, and oh, okay, this would make more sense for end-to-end. I want to test a complete user interaction to see how it would look like in the browser, how the user would interact with it. Then I would typically go for end-to-end test. But I mean, yeah. So another factor is speed. Unit test is very fast because it's just like a piece of code, just one component of your code. Just test it in isolation. It is pretty fast. Integration is, I mean, moderate. End-to-end is slow because of the dependencies. It's not like it's slow, but compared to the unit and integration, it is slow in this context because of the dependencies. you would spin up a Chrome browser or any other browser you want to use on the interface. It would give you options. It would spin that up. You would click around just like a normal user would do. So it's slower than integration and unit test. So I mean, I always try to go for integration, but when it is a complex feature, I go for end-to-end, basically. But unit is the fastest, because you're just testing a piece of code, no external dependency, very fast. Integration is faster than end-to-end, but I mean, slower compared to unit, because now you have multiple components coming together and then you're testing them, their interaction, and whatnot. Confidence. Unit test is low to medium, even though it's very fast, because you're just testing a piece of code, right? Integration is like medium to high, because now you're bringing different code together to see how they behave, different components. But end to end is, you have the highest security when you write end to end test, and it passes because you are testing the complete user workflow and you are seeing how a user would basically interact with your code and the outcomes, right? So it is high because you have all the components required on a page coming together. You write your test. Oh, this is the expected outcome. I write my test. It passes. It's slow, but it gives you the highest confidence because it has the whole flow, right? Just they have a checkout feature where users can add to cart, they click on checkout, it goes to checkout, they try to make payments, put in their card details, every of those things, every of those flow, you do it with end-to-end test. And if it passes, it tests the edge cases and all of those things, and it comes out well, you are rest assured that, oh, okay, my code is fine, right? But if it was end-to-end unit test, you can't test that flow with unit test because maybe you just test the checkout separately, you test the payment part separately, maybe the form to pay separately, you would test the cart separately, right? You're not bringing it together to test as a whole, right? Separate components. But end-to-end, what end-to-end means is bring everything together as a whole feature, and then you run your test. It's slow, but I mean, that's why most times I basically use end-to-end for complex features. I try integration first. When it's becoming complex, I say, I think it goes to end-to-end. So because of the speed, basically, cost. Now, cost is not money, basically. Cost can be in terms of time. So time to write unit test is very like fast because just less than a piece of code. Integration is slower than unit, but faster than end-to-end. End-to-end test is much more difficult to set up, right? It takes more time to set up compared to these other ones. I can write a unit test in like 5 seconds, 10 seconds. It's very fast to write and to set up. Same thing for integration is, I mean, not that fast compared to unit tests, but when it comes to end-to-end, it is very slow to set up. So just like it is slow to run, it's very slow to set up. Another thing with cost is maintaining it is because basically you use end-to-end to test complex functionalities. So to maintain it is very difficult. It's not difficult in actual sense when you think about it, but in context of, oh, we're comparing to unit integration, then it becomes it's more difficult than this too, because I mean unit is a piece of code. If I change my code, I can easily change the test and see, and all of those things, small bit by bit, right? It's very simple, and I mean the cost in terms of time and maintenance is lower than integration and things. Debugging, very easy. I have my button. There's something there. It's just a simple button that click label. It's just a simple user card component that renders my user information. There's no interaction. There's no external factor. There's not 2 or 3 components coming together. I mean, so it's very easy to test. It's very easy to debug. Same integration is moderate because I mean, but end-to-end is hard. Not hard, I would say again, but when you compare to unit and integration, then it becomes harder. I don't know if that makes sense. Let me explain it, but yeah. It's hard, but it's not hard. It's hard when you compare to integration and unit. It becomes much more complex, right? Because you're testing a whole user flow. You would test a lot of edge cases, um, different things that you want to test just to make sure that everything works fine. So it's hard to debug because I mean it's long. You test different things, you do different things, just like a normal user would interact with your application. That's how you write your end-to-end test. Basically, you think like a user. How is my user expected to use this application? That is how you write your end-to-end test, exactly like that. So that's end-to-end test. So that's like comparison between the three most common testing principles: unit, integration, end-to-end. Yeah. Okay. So there's a common pyramid, we call it test pyramid, where it's like a guideline to say, oh, this is how much each test should have. So unit test should be at least 70% of your code. You should, I mean, write at least 70% unit test, integration 20%, end-to-end 10%. Now, end-to-end is, so this arrow shows as you are going up from unit to integration to end-to-end, it costs time. Cost increases and time increases, right? Time to run, time to set up, time to write your test. And this shows number of tests you should have. So the lists in your application should be end-to-end, then integration, then unit. So we have like this application in where I work, where, like I said last time, it's a monorepo. We have like 5 different applications, React applications managed in a monorepo, and we have like a shared library, shared design system library. So right now, our test runs for like 20 minutes on the pipeline, which is bad because we have a lot of end-to-end tests. I can't imagine my PR just run my pipeline and it's running for like 20 minutes. Time to set up the test, we have a lot. So, I mean, we didn't follow the principle basically, though. I mean, that's bad. But yeah, we're refactoring and trying to move some unnecessary tests to integration tests just to make sure our pipeline runs faster, right? So basically, this is like the pyramid. You should have more unit tests in your code. I mean, if you write React, React is a component library. It's a library, it's not a framework. They expect you to have components that you bring together to build a feature. So your unit test should be at least 70%, your integration 20%, and your end-to-end should be 10%. So basically, you need to write more unit tests, less end-to-end tests. It might be tempting to move everything to end-to-end when you start writing end-to-end and you enjoy it, but don't resist the urge because it would affect your pipeline. It becomes difficult to maintain at some point. It takes time to run, but it gives you the most confidence. So it's like, I don't know, contradicting. It's the best, but it takes time to run. So, but if your code is well structured, your unit test and your integration test, once you write those, it would cover for it 10% of your end-to-end for complex functionalities. Then you're good to go, basically. What else? Oh, okay. Okay, so you have common pitfalls and mistakes that people tend to make when writing tests. I mean, when I started writing tests, first period I worked on, it was mandatory that I needed to write tests, at least 90% coverage on the test. If you don't have 90% coverage, then your pull request would fail, basically, because we have like this set of rules on the pipeline that says code coverage must be this. I was, what would I test? I've tested the code in the browser, it looks fine. Why would I test? And all of those things, right? But I mean, some things people do wrong or common pitfalls and mistakes. You don't need to test third-party libraries. That's a no-no. Say, for instance, I'm using a calendar picker or a Bootstrap JS in my React framework or my library or in my project, my React project, and I'm writing tests to say when I click to open the modal, the Bootstrap JS is called. That's no. You shouldn't be testing that. You should test the behavior of your code, not what the library does. So I've seen some people trying to test the library, or I click on this Bootstrap function is called to open the model. Nah, you shouldn't test that. You should trust the work. That's why you need to check the library you are using. Do they have tests in their code? That's that. It's left for them to write their tests, right? You should trust the work. So you need to check what library you're installing, what library you're using, not just for test alone, also for security sakes. You need to check, you need to run checks, so you don't install a library that has like security hotspots and then you affects your code or exposes your code. So you don't need to test the intricacies of third-party libraries. No, just test this behavior of your code, what you've written. Yeah. So implementation details, right? You don't need to basically test that. Say you have a class that has like a private function and public functions. The private function is in the class, it's not exposed, right? Let's say I have a private getter that says get name. I mean, this might feel abstract, but that's like the example that comes to mind. You have a private function or getter in your class that says, oh, get name, right? And you have a public that's exposed, a public function, and then you are testing the private implementation and also the public implementation. No, you should just test that, or when I use this class or this function, this is the expected outcome, right? Should not be testing how the class comes about the solution, right? Should be testing what the class should give you. If I pass in 2 plus 2 to this class, the expected outcome is 4, right? Should not be testing how the class came about the solution. We should be testing what the solution should be if you pass on the required props to the class or to your component. So that's like common mistakes that people are trying to test how the results came about. I mean, should focus more on, am I getting the expected result? Yes, no, right? So styling or CSS, I've seen people trying to check maybe class name on the button, the passing the class name, and they're writing tests to say, oh, the class name is showing in my button. Nah, that's no. You don't need to test that. I mean, at most you could write, if it's a design system, you could basically write like a snapshot test for it. So in case the class changes, your snapshot will fail. But testing to see, oh, there's this class added to the component. Nah, that's a common pitfall some people do. So I mean, CSS, no, you should test the behavior of your component. I click on this button, this is meant to happen. An admin user should not see this. So only a super admin should see this button. That's a good test or a good test criteria to do. Just like the one I showed earlier, loading, error, delete, edit, states, and all of those things. Yeah, that's testing the behavior of your component, how a user would interact with your component, right? As a user, you say screen, you want to search, I grab the inputs, I type into it, what's the result? That's a valid test, right? Not testing the internals of the library or components you're using, or testing if when you click on an input field, a particular class is added to it. Yep. So common mistakes. Some people try to test the framework instead of their code. Just like the example of Bootstrap I gave, we're trying to test Bootstrap scripts to check if the script is called. No, just test when you click on the button to show the modal, your form is shown, and all of those things. Yes, okay, I'll come to that. The overly complex test setups, that's another mistake. Keep it simple as possible. Another mistake is not testing user interactions. I mean, that's why we're writing tests in the first place. Check out users would interact with our code, basically. So I'm going to answer this question. Yes, you can definitely, because accessibility is user interaction also, right? And tabbing around, right, on the screen. If your application is built, I mean, every application should be built to like accessibility should be built into everything, basically, right? I mean, a good application should be accessible to everybody, right? Yes, you could definitely write tests for accessibility, definitely, right? Definitely tab around and all of those things. And yes, there are other tools to check for accessibility. I have like on my laptop, I have Chrome extensions. Almost every application I build in my current company has to be accessible. It's a requirement. They have like a package or software, whatever, on their hand. Once we release the application, the next thing they do before users start using it is accessibility. They do the checks. So sometimes we write tests for accessibility, but most times we have like a Chrome extension that I use just to check, go on the page, run the accessibility checks, get the feedback, go to my code, I fix them, run the accessibility check, and all of those things. Definitely, you can write some tests for accessibility, but you could also use like other tools to check and fix accessibility. Basically, I mean, every application should be accessible to everybody. It's a good practice. Okay. Okay. And then codes, come out under codes today. Clean code always looks like it was written by someone who cares. If your code is not clean, you don't care. Because the next person to come and work on your legacy code would definitely not be happy with you. So basically, try to write clean code and try to have your code tested as much as possible. So anybody inheriting your code would be happy with you. So clean code always. So I don't know if anybody has questions. I've had like a demo project, but I don't know if there's a time set up.
I think we have some time if you want. One question I would like to ask is what are the tools that you recommend for testing with React? What are the libraries that you're using now?
Okay, so as your test runner, you could basically use vtest or Jest for your test runner. And for assertions, you basically will use React testing library. It's made by the React team, and then Ken C Dodds, which is like a key member of the React team, right? So we basically will use React testing library. For your end-to-end, there are two obvious choices, which are Cypress or Playwright. Playwright came into the market of recent, but it's really good. It's more lightweight than Cypress, so it runs your tests faster. One of the problem with Cypress, it takes time to load. It's slow, but with Playwright, it is a lot faster than Cypress. So that's why a lot of people are moving to Playwright right now. Cypress is slower, but I mean, it's legacy. A lot of people already have it in their code. But these days, people are writing more Playwright, are using more of Playwright because it's faster. Like I said, my company, my pipeline runs for like 20 plus minutes, and that's bad. So Playwright is faster. So basically, for complete testing, you need end-to-end integration. Basically, we use Vitest or Jest as your test runner. You would basically use Cypress or Playwright for your end-to-end test. Then React testing library for your assertions for unit and integration. Let me see. So here, for example, here I'm using Jest, right? As my test runner, right? And then I check my package. I just need to run. Where's my test scripts? Just need to run Jest. Once I run test, Jest just runs all my tests. So right here, Jest is my test runner. I think I have an application where I'm using vtest. Yeah. So here I'm using vtest as my test runner. Just helps you run your test. But everywhere you're still using React testing library for your assertions, like to check, okay, is this there? Is this there? Is this there? Is this there? So Jest or VTest for your test runner, and then use React testing library for your assertions, and Cypress or Playwright for your end-to-end test.
Dummy question, what's the difference from Jest and VTest?
VTest. It's the same thing. Like Jest, it's been around for a long time.
Yes.
It's just like saying Apple and Samsung, double phones, they do the same thing. Jest and VTest, they do the same thing, just different people.
But
right.
you are using both together? VTest?
No. In this application, I use VTest.
Okay.
In another application, I'm using Jest. So yeah, this another application I'm using Jest.
Okay, that's why I got confused. Okay, so you're talking about different applications. Okay.
Yeah, I'm using VTest. That's my Jest, as my test runner, just to help you run your test, basically.
Okay, I see.
Yeah.
I don't know if anyone else has questions. I have just one more. What would be the recommendation if you wanted to, from legacy, imagine that you have even not Jest, it's even older library. What would you recommend for a transition phase to migrate from this old legacy library to testing JavaScript and TypeScript and React in this case, but to migrate to a new test runner? Like, do you have experience with that, or is there any tip to do that?
I get your question. The legacy code, does it have any test in it?
You are moving from one library to another library, for example, right? So if you wanted to migrate to a Jest, for example, or VTest, what would be the steps on from one library to another to keep it running and your tests compatible or something like that?
Okay, so say you are moving from Jest to VTest, or
or even something older than, I think there was even older library before Jest. Yes, correct. So that's like intern.js, for example. This is some of the case that I'm talking about now. Like, if I want to migrate and keep compatible, how would you approach this?
I don't know about some other ones, but I would just use VTest and Jest as an example, right?
Okay.
So the first day will be to, I don't know why you would want to move, maybe because it's a new technology that is better, obviously, maybe.
Yes, of course.
So I mean, the first thing will be to check the documentation of what you are moving to, right? That's like the first thing, check through the documentation. VTest and Jest have like really good documentations, right? So the first thing we need to check through the documentation. So I'm going to go through like VTest, for example. They have similar, that's the thing about VTest and Jest. They have, so for React, basically, they're just your test runner. They're not doing a lot of things in your code. What is doing the most in your code is the React testing library that you use for your assertions, right? But for Jest and VTest, for example, what you use them for apart from running your tests is you want to mock. So I'm going to show you an example. Look at this. I'm mocking in VTest. This is VTest. Yeah, I'm doing v.mock. It's your exers, right? And then I'm going to show you Jest. They are similar. Where are you? Yeah, I'm doing Jest or mock. Sometimes they are similar. Sometimes they're different. So what you need to do is you need to go through the documentation basically and try to understand the differences. Try to understand the time it will take to migrate. So what you are migrating to, see what is portable, right? That you could move from your old application that's similar and it's easy to move, see what you need to change, and then you do it little by little. You could still leave Jest in your application and add VTest, right? And start changing. Don't try to change everything at once. Change gradually.
And but okay, which one do you recommend better, Jest or VTest? If I'm going to start now, which one should I start?
Go for VTest, basically, because VTest is much more new and they fix some of the things with Jest. It is faster. Vit is also a bundler that is a lot faster. So it is faster. So I would definitely say go for VTest. Yeah.
Thank you. Does anyone has any more questions? I can keep asking questions here myself. I do have many, but I don't want to take your time to ask questions if you have any.
Hi, Wilson. Well, I just had just about how often in companies is compulsory to, like, they make compulsory to write the tests, or if it's more like a decision of the developer to do it. So yeah, like I wanted to know, like, is how often in the market, like in the companies, they actually make compulsory that, or if it's more our decision it's our decision to do it.
So I would say a lot of companies these days require you to. I think it's a more from what I've seen in the market, right? I think more companies these days require you to at least have an idea of how to write tests. So all I've seen is in startups, right? When they try to, most startups don't, when they begin their project or their code, don't integrate tests into their code because they're trying to move fast. But what I've seen is after they maybe launch and become a bit stable, they start adding tests to their code base. That's what I've seen. So it gives you an advantage, right? So I'll like give an example of myself, right? A couple of years ago, I was trying to get a job, right? Applied to this company in Sweden, did my interview. They were looking for a mid-level engineer. I was like a junior engineer then. And they gave me a take-home assignment. And in the conversations, there was no test. In the requirement, there was no test there. I did it. I wrote tests. I submitted. And a few days later, the CTO called me. I was like, oh, we know you are still junior, but you write code like you mid-level engineer. He even added tests. We don't have tests in our code base. And I got the job. Right. So I'll say it gives you like an advantage. And from what I've seen these days, if you check a lot of job listings, you would see test as a requirement from what I've seen. So even if your company or even if you don't use it right now, I would say try and learn, integrate it maybe into your side projects. It's not a wasted knowledge. Your next job could require it and you would be better for it.
Yeah, I think just to say on that, Veronica, also, there are not many companies that are doing tests, to be honest, unfortunately. But you as a software engineer to build your own foundation is good that you know how important and valuable is the test and the TDD in this case, for example, to make better code, testable code that you can actually understand what's going on, that others also can understand. So if the company it's not asking for that, if they are not asking as experience for you to become a better engineer, it's a must. You need to know how to test. You need to test. You need to invest time on that. For you to feel a better engineer is like for you as an engineer is important. That's my experience or my say on that. I think some companies, they don't really do that, but you can feel that and you can own that more as your learning opportunity to do better.
Mm-hmm.
Thank you very much.
Yeah.
Okay, do we have one last question? Please feel free to ask. If not, then thank you everyone for attending today. We are going to share the recording later, but also I think Wilson would be happy to hear more questions. You can post them in the channel. And I hope maybe Wilson, you also can share the demo project that others can have a look and try it out. And maybe in the next meeting, you guys also can come with some questions so he can also drive, or you can post in the channel in our start group and we can discuss about them. Okay. Thank you for joining. Thank you, Wilson, for your time and for your very nice talk. This is one of my favorite topics, so really appreciate your time.
Thank you.
Thank you.
Thank you. See you next week. So,
Bye.
goodbye.
Thank you. Bye.